day everyone, I will discuss you the Quicksort. The algorithm was developed by a British computer scientist Tony Horn in 1959. The name Quicksort comes from the fact that Quicksort is capable of sorting a list of data implements significantly faster, twice or thrice faster, than any of common sorting algorithms.
I'm Cheryl Iguansha. Good morning, everyone. We are back to another video, and our topic for today's discussion is all about Quicksort. What is Quicksort? It is a divide and conquer algorithm. It picks an element as pivot and partitions the given array around the picked pivot. Also, it is done while dividing the array into sub-arrays, while in the case of merge sort, all the real work happens during merging the sub-arrays. In case of Quicksort, the combined step does absolutely nothing. Partitioning an array. The initial array where the pivot has been marked. The first two elements are each compared with the pivot, and they are swapped with themselves. The next two elements are greater than the pivot, so they remain where they are. The 2 is smaller than the pivot, so it is swapped with the first element available. The 7 is larger, so it remains where it is. Finally, the pivot is swapped into the correct location. The array has now been partitioned, and the index of the pivot can be returned.
Today, we're gonna learn about Quicksort. Like merge sort, Quicksort is recursive algorithm. However, we need to give Quicksort. You need to think about pivot. Do a certain calculation. These additional operations are sometimes for algorithm to work at all. First, the pivot correct position in final sorted array. Items to the left are smaller, while items to the right are larger. Okay, so let's look for the example. Okay, for now, let's choose a pivot. I'll explain the best way to do this later, but I would choose pivot 3. First, remove the pivot to the end of the array. After we remove that, the next we're gonna look for two items. Item from left, which is the first item, is the larger than pivot. Second, item from right, which is the first item, starting from right, that is smaller than our pivot. Starting at 2, we can see that 6 items from left and the item from right 1. And then let's walk from item from left to item from right. We repeat the process. This time, 5 is item from left and 0 is item from right. And after that, again, we swap the 2. One more time. This time, we shouldn't item from left has a greater index. Item from right that we know we're done. We swap item from left and pivot. 3 are pivot. Is now in a curse box. To prove it, let's review our trick. As you can see, all items to the left are smaller, and all items to the right are larger. We said Quicksort is recursive. Let's go to the process one more time with the larger position we just made. We choose 7 as a pivot and move it to the end. I let you to watch this without voiceover. Now we have 3 and 7 in the correct position. And I think you understand the concept. One of the important questions is how to choose the pivot. This makes a large difference in performance in algorithm, as we wanted to choose a pivot that's the range half or as close as possible to even at work. Our method is median of 3. This method will look at first, middle, and last elements of the array. We sort them properly and choose the middle item as own pivot. For making the guess that the middle of 3 item could be close to median of the entire array, as you can see, it is not far off. Here's the zero code of Quicksort.
Quicksort has the worst case time complexity of big O of n squared. But if a pivot is chosen properly, it can be shown to have an average case of big O of n log n.